doors, huh? Okay, doors. Swing. Am I dreaming?
No.
Where am I? In bed? What am I doing? Talking to myself.
Look, I must have a star on my door.
Or better still,
A door.
swing doors, huh?
Okay, doors.
Swing.
Now I know I'm dreaming. How do I get this sleep? What about those bars on the window? 1, 2, 3, sleep. Please let me sleep. Poetry. That'll work. Come, sweet slumber, and shroud me in thy purple cloak. Doesn't even rhyme. Is that my tea's mate?
Paranoid.
I can't stand tea.
Good evening, folks. Welcome to HAXoDROME, the third episode. And just making a greeting out to everybody that's currently watching right now. To those at ProSoft. Hi, guys. How you guys doing? Nevin, Kentaro, Carlos. Hope you guys enjoy tonight. So, for those of you who are new, HAXoDROME is a show about hacking, about embedded development, you name it, all kinds of different things. So, for tonight's episode, we're going to be doing some audio work, a little bit more in some more detail. So, with no further ado, let's see what we have on our table today. As you can see, it's quite messy. We have a Mega ADK with some breadboards that we're going to be using today. So today's main focus, again, is just going to be audio and trying to get audio to work. Now, I know you guys might have questions from the last episode if you guys watched it. So if you have any questions, feel free to ask them now. As you can see, I rearranged the room a little bit, and of course there's not going to be any interview today. Next week there will definitely be one. I'm hoping. So, Nevin. I just got your response right now, Nevin. There's going to be about 3 to 5 minute lag. So when you type in a message, if I don't get to it right away, it's just because of the lag. Again, without any further ado, just want to do one more shout out to Eric. Hey Eric, what's going on? Thank you for joining the show, and everybody else who's watching right now. In fact, before I begin, I'm going to make a little post right now so everybody's aware that, hey, the show is officially begun. So, one moment, please. And as I do this, go ahead and ask any questions you may have, and I will be happy to answer them. One moment. This is a live show, so everything that happens live, so to speak. So now that I got all the social avenues tricked out, just making sure I'm just running some tests right now with the camera still. Making sure we're okay. It looks like we're fine. Camera check. Camera check. Cool. So, anyway. Going back to what we had. So, last week we had basic... one second. We got basic audio working on a piezo buzzer. That was awesome, but it could only produce one tone, which was not so awesome. So I did some research from last week until this week, and I did find a better stash of classes that I could use to generate a tone. With all I would need is just a 1K ohm resistor to go right into the RCA jack. So, without any further ado, let me go ahead and show you the class and what it's called here. And one moment as I bring it up for you guys to see. Now, some of you might be noticing, wow, everything's so old-fashioned and retro, and that's, well, because everything is shot analog. This is like an old-fashioned pirate hacker station thing. So, anyway, here's the library that I decided to take. It is called the Arduino Tone Library. Let me make it a little bit bigger so you guys can see, because the monitor isn't so good, because it's black and white. Go figure. So, the Arduino Tone Library can allow you to produce tones of multiple frequencies using something called a PWM, or pulse width modulation. And Nevin, you and I know it very well with the DAC. So, the Arduino Tone Library is very simple to use. In fact, it's extremely simple to use. So I want to experiment with it today to see what we can do with it. Now, since we'll be using a Mega ADK, this is the standard Arduino, the Arduino Uno, but we're big boys, so we're going to be using the Mega. And all I need is a 1K ohm resistor to wire her up and get it going. So, without further ado, I'm going to look for a 1K ohm resistor. I know I have one, because I have so much junk here, I don't know what to do with it. So let me find a 1K ohm resistor, and we'll begin by... Actually, you know what? Let's begin by taking the Mega ADK board and loading a sample sketch that just plays a few tones. Now, I'll be able to show you what the source code is. Now, if you guys, again, have any questions, let me know. Please. This is a learning process as we go along. So with the Arduino, of course, you have to use a serial cable to plug into the board, as follows. Like magic. So, let me go and plug in my board. I'm all out of USB ports. That is not good. I should have planned that ahead. Anyway, let me just plug this in. Now, some terminology to know. I wonder if I'm coming in on a wireless. You guys might be experiencing some lag. If you guys are having any issues with the stream, let me know, because it might be a connection issue that I have. Just FYI. I think I have it plugged in. It's hard to tell. Okay. So, we're going to produce just some simple sounds for right now, using the libraries for tone. The Arduino Tone library. So with that being said, let's open that up and start experimenting, shall we? So, let's open up a new sketch. Oh. 1 second. Now, with the Arduino, just as a rule of thumb, the Arduino has two important functions, if you guys remember clearly. The setup function and the run function. So we first have to do a setup and then execute it with the run. The run loops forever and ever and ever. So, going back to the screen here, we'll be able to do just that. One moment while I get everything set up, and I'll begin typing. So, void setup. Notice I'm not using a pre-made demo. I'm actually going to be creating this simply out of memory. Actually, before we even do that, let's create some tones. Tone 1. Again, this is using the tone class. Tone 2, tone 3. We have 3 different tones with a class called setup. One second. I lost my place. Okay, there we go. Now, the Arduino class for tone is really simple. All it does is you just begin on the pin that you want to make it high for. So let's say pin 13, 12, 11, and so on. And from there, you just make the frequency, or you set the duration. The classes already come the class or the library already comes preset with some tones that you can use. You can either put in a frequency of your own choosing, or you can use one of its constants, which are just static variables in all capitals, like note C4, note E4, note G4. Let me show you what I mean by that, actually, so you guys get an idea of what I'm talking about. So I'm not just talking out of my so-and-so. So, as you can see, the library already comes with a constant name and a frequency in hertz. So we have different notes that correspond to the different frequencies. And I'm going to be using the notes, like note A5, note B5, and so on, to produce these sounds. And these sounds will be played through the Arduino's pin to the RCA output. That's it. So let's see what we can do with that. Moving that over. Now, do you guys have any questions at all? Please let me know at any time. I see, Eric, you're having some difficulty. Now, is this everybody that's having difficulty watching this? Because if it is, let me know. I might have to change up the wiring. Who knows? Anyway, back to the show. So, now we're in the setup. Void setup. And the first thing we want to do is make some pins go high. So for tone 1, I want it to begin on pin 13. Tone 2, I want that to begin on pin 12. Tone 3, I want that to begin on 11. Pin 11. So these pins right here are... There's two different major kinds of pins. Okay, so I do apologize for the stream slowness tonight, guys. I think I know what it might be being caused from. In my town right now, they're doing some renovation on the internet signal here, so they kind of dropped the speed a bit. So if it does cut out, I do apologize. Next week, we won't run into that issue. But going back to the Arduino itself, let me pull out another Arduino because I have so many of these guys here. So let me show you on the table what exactly I'm talking about. The Arduino has different pins that do a series of different things. So mainly there are digital pins and analog pins. The digital pins go either high or low, meaning there's a constant voltage of either 5 volts or 0 volts for low. So it's like a 1 and 0, 1, 0, 0, 1, 0, 0, 0. So that's the digital part. The analog part is variable in voltage. Now, the analog can, like I said, vary in voltage. And the digital pins, there are a few pins here that are noted for PWM, or also known as pulse width modulation. Now, these pins are the pins that we're going to be using tonight. And the easiest way to tell for the pulse width modulation is that there'll be a little tilde next to the numbers printed on the board. That tilde identifies whether it's a pulse width modulation or not. Now, pulse width modulation, think of it like a frequency. Yeah, like a sine or a cosine wave. To put it lightly. I mean, I don't want to confuse too many people. So, yeah, we'll be using a PWM pin in order to get this to work. Let me just make sure here. Maybe we won't need to. Who knows? I'm going to experiment, and that's the whole point of the show. If the stream is if the stream is really bad, just move the scrubber bar or the play bar just a little bit back, maybe just like 20 seconds back, because I mean the lag is already 5 minutes anyway for asking questions. So if you want to buffer it, just move it back slightly, about 20 to 30 seconds, and that should give you enough, buffering leeway in case it's a little too slow. Anyway, back to the tones that we're going to set up here. So I have tone 1, 2, and 3 beginning on pins 13, 12, and 11. The next thing you want to do, because I don't want this, you know what? I'm going to close this and say, okay, I'm done with the setup at the beginning on those pins. The next thing I want to do is say void loop. Now this is the actual program. Now I might have said something else different, like begin, which is incorrect. Sorry, it's void loop. So tone 1, I want it to play the note of C4. Tone 2, I want you to play the note of E4. And tone 3, I want you to play the note of G4. And you notice I put a semicolon at the end of every sentence here. And that is just standard coding practice. Just at the end of every line with C and C++, Java, and a few other languages, you have to put a semicolon that denotes the end of line. You might have heard end of line in actually a film. Tron did that all the time. It was cool. I liked it. What can I say? So anyway, here is our little sample code that's going to play some tones. I also wanted to do one little thing before that. Just because my TV requires a video sync for audio to work, go figure, I'm going to do a little, what do you call it, a test for the video signal. I'm going to just have text appear. Just simple text. So, with that being said, oops. One moment while I open up my little sketch here. Now, do you guys have any questions right now? If you do, please ask away. Ask as many questions as you guys feel like, because I may have an answer for you. As of right now, I'm just getting a few things set up at the moment. Okay, now I'm going to do one little thing here just to give a video signal, because we're doing not only video but audio here today. So I'm going to move all the way up to the beginning of my program here, and I'm going to do a few things here that you may or may not know. Now, you're going to see this called include. these statements, these include statements, mean to the Arduino IDE to grab a file outside of the Arduino IDE and bring it in. These files give it extra functionality that otherwise would not be able to do. So I'm going to bring in the TV out libraries for that video signal that we had, so that we can get video and fonts working. And you'll see here in just a minute what I mean. So going back to the include, tvout.h is what we need, as well as include font all.h. So we're going to include our TV out library plus all of our fonts. And just below that, I'm going to say, hey, I'm going to create a new object of TV out called TV. Now, you're probably thinking, what? What's an object? Now, Frank, you're just getting freaky on me. What's that mean? An object, well, I'm so used to knowing what an object is. It literally is an object. It's a something that the code. It's like an identity of a certain type of thing that the code uses to recognize. Like, for example, I created an object of a TV out signal called TV. So anything that TV out has, like synchronization, such as fonts, such as graphics, it's going to be all in that object. It's like a box, like a box. Say this is my TV out box. And I called it, Larry. I call this box Larry. This is my Larry box. He's a TV out. And inside this Larry box, I have all these cool functions I can use to do something neat, like synchronize signal. And I think this can erase, even though it's permanent marker. But if not, I'll have a really cool box named Larry. Anyway, back to the code. As we see here, we have a TV out object called TV. And I am going to get everything all set up here. So we have TV, tone 1, tone 2, tone 3, begin. Now I'm going to do all the TV functions. So TV, begin, and I'm going to do NTSC, width and height. Now you're probably thinking, Frank, what is an NTSC? I'm scared. NTSC is a television signal used in the United States. It's a standard. Other countries use PAL, P-A-L, and it's the difference between NTSC and PAL, or what they even are to begin with, is they're like a protocol of how signal is sent through a composite line and onto the TV, and how the TV interprets. All right, Eric, you asked for it. This time, I'm going to use some music.
No. Where am I? I'm dead. What am I doing?
I totally forgot the audio. So, I lost my train of thought. Okay, NTSC and PAL. They are they're just like a protocol that sends out to the TV set. The TV set uses something called chroma and luma to decipher the signal, because the television, the standard idea of what a TV is, back before flat screens came out, where you had this big glass tube, this cathode ray tube. And this cathode ray tube, I'm just sorry if I pause. It's because I'm reading the comments. This cathode ray tube does something called a scan line. It sweeps a beam across the screen at a really fast rate, 60 times a second. And what it does is it creates intensity of light, or no intensity of light. That's the chroma. I might be confused. It might be luminance. Luminance. Yeah, luminance is how bright and how dark. That's how black and white TVs were back in the day. They just had luminance. So it's how bright, how dark, how bright, how dark. And that made black and white color. Or black and white, sorry, not color. Black and white signal. Later on, when TVs became color, they added the chroma. And so, yeah, that was the intensity of red, blue, and green to produce color. Alex. Okay, Alex, I'm gonna do an impersonation of an old professor of ours. He did a lot of embedded. So,
Mipsy, you got your MIPS, your signal right over there. Yeah.
that one's for you, Alex, and Joshua, who's watching, and whoever else who's watching. So, I can't believe I just did that. So that's how NTS signal works. Going back to that, now you understand why it's called NTSC. It's just a protocol because my TVs are all American over here. Anyway, so from here, I'm going to do a TV dot select font 6 by 8. It's just a font, arbitrary font name that they use. I'm not too sure as to why. So, now that I have the select font ready to go, I'm going to go down to the loop and say TV.println note C4. I'm going to move this guy over on top of tone 1 right here. I'm going to do the same here for E4 and G4. So now what's going to happen is it's going to play on, it's going to display as it changes. Going back to that, I think we have what we need. Let me go ahead and verify. Oh no, what happened? Why is it complaining? This scope error, note G4 was declared in this scope. Oh, 1 second. I have to restart Arduino because I put the tone libraries in before it was actually usable. Go figure, right? One second. One second. I'm getting a lot of... I'm answering some questions right now. So, sorry, I had to pause there for a moment. Let me go ahead and just do a quick debug here of the Arduino sketch. Wherever I saved it. Shoot. I closed it, but I didn't know where I saved it. Isn't that a bright idea? Oh, son of a gun. Got it. Found it. Alright, let's verify. Tone. Oh, whoops. I made a little mistake. I forgot to include one line of code that's actually kind of important. Let me show you what I'm talking about. So, remember what I said about the tvout.h? That's kind of important to give tvout its functionality. I forgot one line. Tone. The tone libraries need to be imported too. That was a stupid mistake on my part. So let me go ahead and import the tone libraries. Simply by typing include tone.h. That's it. We compile it. It's compiling the sketch right now. So far, so good. Uh-oh. What happened? I take it off the screen so I can debug it. Let me do a quick debug here, see what's going on before I say anything. Digital light. 1 second while I make some changes here. Because this thing is being not very happy with what I'm doing for some reason. I'm recompiling the sketch right now. Now, do you guys have any questions? So let me show you what I'm seeing here. And it's an error. And it's going to require some debugging because I don't know where or why it's calling the way it is. Let me show you. If you guys can even see it. Okay, it's very light here. says program file, CPP, error, digital pin to bit mask was not declared in this scope. So there's a few things not declared in scope for some reason, and I need to figure out what, why, and where they're not being called in scope. So I gotta figure this out. It might be a little while, just because this is very obscure. New library's tone to the newer function void. Error bit right was not declared. Bit right was not declared in scope. I'm debugging it. While I debug, please, guys, ask me questions. Stop. Alright, I'm messing something up. I've got to be messing something up here. What could I be doing wrong? Oh! Okay. Tone 1, stop. Tone 2, stop. Stop. Let's see if that works. I'm still debugging. Thanks, Nevin, for joining. Have a great night, Nevin. Thank you. So there seems to be something going on here that I don't know why it's doing what it's doing, actually. Let me try something here that might be a benefit. There might be an example tone library that I can use. Aha! Digital right was not declared in this scope. So there actually is something wrong with the Arduino library for this. Because I just loaded up a demo tone library and it's not working. Let me do a Google search to see what I can find. See, this is what I mean by coming a little more prepared for the episodes. You guys don't see me just sitting in front of the computer. But let me ask Josh's question. I'm curious why my name is green, but everyone else is blue. Because, Josh, you're the one talking. It's whoever is the live person. It's whoever is the person asking the question. You're green just so it makes you different from the rest of the people talking. Let me figure out what's going on here. Because that is really weird, and I don't know why it's doing that. Aha! Looks like other people are having this issue too. So the error that's being said here, one second, the error is actually caused by an update to the new Arduino library. So I have to make some changes. So while I experiment with these changes, I'm going to show you guys and the world as well as to how I'm going about these changes. So whoever needs to use this library doesn't have to go, what the heck is going on? So, come join us to the land of digital, or analog, or whatever it is. So, I went to one of the forums here, and it says all the same thing that I'm getting, and the guy says, that version of the tone library has not been updated for Arduino 1.0. Change wiring.h to arduino.h and see if it's the only problem. So, let me do just that. Let me flip my record over as well. Okay, so no way. I ran out of battery. Well, the record player's dead. Always come prepared, no matter what it is. So let me get some tunes running up here right now. Gonna keep this old school because that's just how I roll. Mixtape. Mixtapes never fail. Alright, so I'm gonna go ahead and make the changes now. I'm going to show it on this screen up here in just a minute. So I need to go to C drive, program files, and then from there I got to go to Arduino. From Arduino, I have to go to hardware, then go to, that's different, cores, Arduino, and from there should be something called wiring.h. There it is, wiring.h. Or wire. Is that wiring.h? Whoa there, buddy. I got a C file instead. Oh, this is going to be really difficult. For Ryan, who's watching us, the reason how I get it looking so 80s is that I'm using nothing but vacuum tube cameras from the 80s and from the 70s to produce the signal. So everything that I'm using is actually analog hardware. Anyway, back to trying to figure out what this is here. So apparently there's a wiring.h somewhere. So I'm going to do it the Windows way. And I'm going to say wiring.h. Find it for me. There's no wiring.h in the Arduino library. What a surprise. There's a wiring.c. For sure, for sure. Okay, well, we're gonna have to choose it and experiment, see if it's actually the .c file. Oh no, I should have opened it. Shoot. Exactly, Alex. Musical birthday cards. Darn it. Okay. Let's see what we've got going on here. Let me move my window over here. With wiring private.h. That's gonna mess up everything. Sorry, I'm having like an internal struggle with myself trying to figure out what I need to do here. So, going back to Arduino, going back to hardware, going back to Arduino, going back to cores, going back to Arduino. I am going to take the bold step and I'm going to change this wiring name to Arduino. Will I regret it? Most definitely. Rename. Arduino. Ooh! Just seeing that makes me kind of cringe. I'm going to reopen Arduino. I'm going to run a quick test here and see if that actually did anything or it just made everything worse. We'll find out. One second. We're going to get tone working tonight, that's for sure. But that's tough. That didn't work at all. Wait a second. Wait a second. Wait a second. I just realized something. There's an Arduino.h already in place. So, going back to what's going on here, I have no idea, because apparently the tone library is way older than the Arduino IDE that I'm using, so it's something's not synchronized, apparently. I gotta figure out what's going on. So, as I figure out what's going on, ask any questions that you may have. I know it's kind of like slow right now, but please bear with me. I have no idea why it's acting the way it is. Apparently, as it goes on, I have to make some more changes. So, with that, let me show you what I'm seeing here. 1 second. I'm going to have to go in and start getting really, like, hairy with the source code here, but that's actually a good thing, because you guys get to see what's going on. So, I'm in the Arduino directory, which you barely can see, probably. I'm going to go to libraries, and I'm going to go to tone. There's a tone C++ file, and a tone.h. So I'm going to open up the C++ file in Notepad++. Notepad++ is the coolest application ever. Just saying. And I need to make some changes here. Let's see here. Change that to Arduino.h. Change from wiring. Wire.h. So I'm changing what's being imported here, Arduino.h. Boy, they just keep changing this. Alright, let's give this a shot and see what happens. It may work, it may not, but we won't know till we try it, right? I'm going to do a test right now in the tone library to see if it'll compile. And my fingers crossed. Come on! Come on! Yes! I got it to compile. So I had to change wiring.h to Arduino.h in the tone.cpp file right there. Where it used to be wiring.h, it's now Arduino.h. Now it's successfully compiled. That's problem solving, buddy. That's daily life as a programmer. So anyway, coming back, now that we've gone through that little lull right there, I'm going to go back to the sketch that we made. Right now. Bringing that back out. So I'm going to compile it. As you can see, it's compiling. There's a little bar right there. It might bark at me because I might have not saved any changes. But if not, awesome. Now let's make sure that we have the right board. Alright, let me plug in my Arduino here. Okay. It should load the driver here in just a second. Alright, it's going to be on COM 5. And in 3, 2, 1. It's loading. It's loading. Ah! Come on, it's almost there. Done uploading. Oh, yeah. All right. Here's the board. I'm going to unplug it for right now because we're now going to start the wiring process. I said pins. What pins did I do? 13, 12, and 11. So, I'm going to move over here. And I'm going to start setting up the pins. Now, Josh asked a question, I think it was the last time I watched. Curious if it was just my internet acting up, because, yeah. No, there's a lag. There's going to be a lag. There is going to definitely be a lag. Yeah, it's gonna suck. But anyway, shabam! Now we are, let me make sure that we're good here. Alright. So, we have our Arduino board. The Mega or Mega ADK. Now I'm going to use a 1000 ohm resistor. First of all, I gotta find this 1000 ohm resistor that I have. It's a 1000 ohm or 1k ohm, kilo ohm resistor, and I'm going to find it and put it in pins 11, 12, and 13. And I'm going to show you exactly where I put them in just a second. So hold tight while I grab a resistor or bunch of resistors. As you can tell, I've made some changes to the room and its setup to make it easier for me to actually use. Trusty thingy of box stuff. Oh, that was a horrible line. Trusty thingy of box stuff. 330 ohms. 1k ohm, a whole baggie of it. I got you a dime bag of resistors. It'll be $39.95. Isn't that awful? Anyway, so I'm gonna take out my 1k ohm resistors here, and I'm gonna start plugging them into the board in the consecutive pins that I labeled. So pins, make it visible here, right there, probably the best place I can put it. Hey Frank, what program are you using to stream? Just curious. I'm using Adobe Media Flash Encoder 3.2. It's probably my favorite, just because there's little BS involved with it. Let me make sure. Begin 13. So pin 13. Pin 12. And pin 11. All wired up, all honky-dory and whatnot. Crikey. Okay. Now, I'm going to try them one at a time before I connect them all together, because I have a feeling that it may cause some weird ohmage issue, and I don't want that to happen. So, anyway, going back to the board, let me get my two other resistors here. Where did they go? For the TV synchronization. You might have seen these two run in sync. These bad boys right over here. Now I gotta remember where I plugged it in. Let me consult the TV out library. Eric, yeah, they don't have a built-in one for YouTube. No. Really? 87. Oh, poo. I'm gonna have to change one of the pins because I was afraid this was going to happen. One of the pins is actually being used for the video signal, so I have to swap that out and just do a quick recompile. You'll see what I mean in a minute. This pin 11 is for the synchronization of the video, and we're using pin 11 for tone 3, which is a big no-no right there. So I'm going to just skip that and go to pin 10. So 13, 12, and 10. Recompiling it. I've tried OBS before this was. That's interesting. Okay. I tried OBS before. I had issues with it. Not saying that it's good, but I mean, I just had issues with it. Okay. Going back over here, I'm gonna wire this up the way it should be. So pin 11. And video synchro. I think this is the right way. It's hard to know which one it is. Right here. So we have our video set up. I'm just going to do one audio for right now. Okay. Awesome. Take a look at these guys right over here. I'm going to plug one for video. Whoops. One for video, one for audio. Video, audio. Alright, now next thing, I'm going to get some wiring here. In fact, I have a whole bunch I can just grab, which is super convenient. Just grab a whole bunch of wiring. Now, it's always important to label your wires correctly. If not, then that's just not good on you. Ground. So I'm going to get my ground signal here for my video. Just like that. Want to make sure at least the video is working, so I'm going to progress. Oh, I don't even have enough cable space. I didn't plan this ahead. My USB cable doesn't reach. It doesn't reach at all. Oh! Hey, I could use that. Little do you guys know, there's actually a computer right behind you in a big screen so I can see all of your guys' messages. So I'm just going to plug the USB into that instead. 1 second. Or 2, or 3, depending on how many seconds needed. Gotta push this thing back to make it fit. Awesome, that was actually convenient. Oh gosh. Ooh, I almost tripped over a wire. Please tell me I still have video. Okay, good. Whew. That was a close one. Whoops. Okay. I have it wired backwards. My bad. So, 11 with this. getting it wired correctly. Give me a moment. Well, it makes sound, though it's the scariest sound I've ever heard in my life. That's a good thing. Let me wire this up. Come on. Okay. Now, I'm going to get the TV working here in just a minute so you can hear. Let me just turn down the volume because that was just really, really loud. What the hell was that? Some kind of abomination. I am unplugging the board. I gotta take a look at my code. Something happened that was not supposed to happen. That was horrifying. And I think I know what happened. The tones that begin happen too quickly. And so you get this really quick pulsing of a sound that's not very good. That was terrifying and loud. Let me see if I can find another USB cable here, because I want to have them both. I don't want to keep unplugging and plugging this one in. But we did get sound. That was a good thing. I'll eventually move over the monitor so you can see exactly what I'm seeing once the program is running correctly. I gotta first make some changes. Well, the thing is, Josh, with FME, that's all YouTube really gives you to use. So they don't give you the option to say, hey, choose something else. They have their own YouTube video uploader streaming service, which just is awful. It's just the worst I've ever seen. And it doesn't work with analog hardware. Adobe's does, though. Isn't that weird? Anyway, I'm going to go back to this again and make some changes, because this, whoops, I'm going to, wow, that's really fast. I'm going to make some changes. I'm going to do something called a delay. A delay is, it's going to hold the screen for a while, and hold, and hold, and hold. And I'm going to get rid of the loop, because what's probably happening is it's going so fast in the loop that it's messing up with the video signal, it's messing up with the audio. So I'm just going to put it in setup and use delay. So it's going to say, play a sound, delay, play a sound, delay. So you get to hear it, and then stops the sound each time. So you'll see it as I make these changes. Going back to here. So we have tone 1 begin, 13, 12, and 10. Okay. This is very, very difficult to navigate. Alright, so. Oh man, you guys can't even see it. Alright, so in the loop, this loop right here, we have the println, the play, println, play, println, play, println, play. So, what I'm going to do is, wow, Arduino, I am going to just have a talk with you guys. I can't select anything. Let me move this over to a bigger monitor here real fast. One thing I really don't like about the Arduino IDE is the fact that when you select something, it's the most awful experience of selecting anything ever. So anyway, you'll notice that the void loop is now empty, and we're going to keep it that way because we don't want anything to loop. So below TV begin and TV select font, we're going to put in that code that we put in the loop. So there it is. Let me add a space here. So now we have, oh my goodness, this is so like nauseating to look at. Okay. Print, LN, note C4, tone 1, play, C4. I'm going to set... separate each one of these by 2. My goodness. Okay. There. Now we have 2 notes apiece. So we're going to do C4 first. We're going to do delay of 2000, meaning 2 seconds. And then tone 1 dot stop. We're going to do the same thing for E4 for tone 2. And tone 2 is donde está tone 2. I'm having a little bit of technical difficulties today, guys. 1 second. The issues, Josh, are that I have an analog encoder. It's a box that converts all the analog signal to digital signal, and for some reason, Adobe Flash's encoder is the only one that works. I don't know why. I have no idea. Okay, tone 2. We'll do delay 2000 milliseconds. And tone 2 stop. Okay. Wow. I am so sorry. This IDE is just not working out today. It's spazzing out. Delay 2000. Tone 3 dot stop. I'm gonna change the font size. I'm sorry, guys, but this is just too big. It's to the point where I can't navigate for some reason. That's a little bit better. There we go. Yeah, now you guys get to see a little bit more. So I'm going to upload it right now and see what happens. It's done uploading, so let's try it out. So I'm playing one tone at a time. It'll go bop, 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 something like that. So let me move this over to our little station up front here. But first I gotta plug it in. Make sure everything's all wired up the way it should be. Okay. just rewire this thing back to what it was. So first of all, our 2 resistors from before for the video signal on pin 11. Make sure that I got the right pin out here. D29. That is definitely D29. On 11 and D29. Perfect. Ground it. So I'm doing video signal first. I'm grounding my video signal. It's very important. Okay. Alright, and now I'm going to do the ground for the audio. What should happen, is one note will play. Just one for right now. And then I'm going to get the other notes playing here as soon as I figure out what's going on. So I'm getting my 1K ohm resistor. Let's plug it in and see what kind of sound we get. Okay. Note C4. Did I do delay of too long? Uh-oh. Uh-oh. What's note C4? Okay, something might have happened here. One is on pin 13. Aha! You reset it. Huh. Well, it was working before. That's weird. Let me check something out here. I got video signal working and I have something that kind of resembles sound, but it's not really sound. Unless it means a different digital pin. One second. I may have mistaken milliseconds for seconds. Maybe I didn't. Maybe it just froze. showing. All it's showing is note C4 on the screen. And that's it. I wonder why. Well, this requires more debugging, so back to the drawing board. You guys have any questions as I go on? Or you guys seem to just be watching and monitoring as I go along? So if you guys, again, if you guys have any questions, comments, or snide remarks, please feel free to let me know at any time. I'm going to find another USB cable because unplugging it and plugging it back in may be tedious real fast. If I can find one, which I don't think I have a spare. Ooh, don't jump it. Okay. A13. I'm going to try something a little bit different here. I'm going to see what I get out of this. Or nothing at all. Maybe that's wired wrong, so let me just check something. Nope. Okay. Something happened, and I don't know what. So I'm going to keep this wired like it is. Take it back on over here. And figure out what's going on over here. So it looks like it's showing the note C4. What should be happening is it should be playing note C4. I think the delay is actually causing an interference, or the stop. So, let me get rid of the stops here. Tone 1. Look how silly that is. I'm moving it left and it's shifting up and down. Do you see that? Oh dear. That is just the silliest thing. Alright, so I got rid of the stop after that notorious shaking there. I may have to use an LCD screen next time, just because that is just not cutting it. Look at that. Let me look at the libraries here for the... I may not have it in a proper pin, but we'll find out very soon. Let me upload the sketch. It may be that it needs pulse width modulation enabled, meaning that synchronized pulse, like a sine wave, in one of the pins. If that's the case, then that's the case. Alright, I'm uploading it now. It's funny, I'm on Facebook, and there are like 5 or 6 people asking me questions, and they're completely and totally oblivious that I'm actually doing a live show right now. They're like, hey, I need you to stop doing what you're doing and answer this question. I'm like, whoa! Some people, man, some people, right? Anyway, I got it back on the board again, and I'm going to wire it up and see what's going on with the sound. It doesn't look like it's stuck anymore. Wiring up the video. And the audio. Now, I'm going to do the audio a little bit differently. I'm going to wire up all 3 of these guys at the same time. It's probably a really bad idea, but you never know. Because if I can do this right... Alright. Well, here goes. Here goes a whole lot of nothing. Ready? 1, 2, 3, go. What did I... The first time, it was producing sound. This time, however, it's not. I don't know what I changed in the libraries to cause what it's doing, but it certainly seems not to be working the way it should. What time is it? It's almost 11 o'clock. I'm going to try one last compile, okay? And if this compile doesn't work, I'm going to make a supplemental video showing what errors I did, because compiling and recompiling and you guys watching it is probably getting very boring really fast. So, let me do one more compile on this board. I'm going to make some changes here and see what happens. Okay, what I'm going to do Let's just take a quick look here at the TV out library. Actually, you know what? I'm going to do a DD when I'm testing. Dual tone demonstration. So what I'm going to do is I'm going to do a little bit, I'm going to use an example library here. And I'm going to build off the example. 1 second. It's going to just take me like literally maybe a minute. And 12 are what pins on here? Let's do pins 40 and 42. 40, 42. You won't be able to see what I'm doing because I am setting up the signal here. TV.begin, NTSC. I'll show you guys what I'm doing here once, if it's working successfully. Whoops. Okay. Who knows what I'll be expecting out of this sketch that I'm compiling. I'm doing a little bit of hacking right now to see what's going on. May or may not work. If it works, that'd be pretty cool. It's done uploading. I'm not going to disconnect it just because it's starting to get a little obnoxious to connect and disconnect. But you guys can't see it now. You know what? For science and learning and hacking and all that, I'm going to replug it in. Here we go. This is the last compile of the night, guys. If it does not work, I'm going to make a supplemental, again, that will reflect what's happening here, because apparently something else is happening beyond our control. I'm wiring it up right now so that they can both make contact to this glorious, glorious, it doesn't even reach, audio circuit. Okay, there's the shield for that. And this will go here. Come on. Come on. Don't make it rough on me. It already didn't work. Yeah, I'm just gonna hold it. Ah, my goodness. It's being difficult. It's not being a very nice Arduino tonight. You know what? Jerk. This Arduino's being a jerk. Ah! Alright, so let me just quickly rewire something. This is not going to work, but I'm going to try anyway, just out of curiosity. That was actually what I wanted to hear, actually. Bingo! I got sound working, guys. Not in the best way, but it definitely does work. That being said, let me try something. Okay, don't touch it. Well, it makes sound. Let me move it on over to the monitor so you can see what's going on. Time to go handheld. Woo! What are we looking at here? There it is. It's making noise. Horrifying noise. But noise nonetheless. It's messing with the synchronization, as you can see. So I got it to work, but it's very obnoxious. It's a step in the right direction. Something tells me it's not wired correctly still, but the fact that it made a noise is important. Okay, that's really important. Well, we just got sound working on an RCA television set. That's really important. As annoying as that sounds right now. Now, the next thing I want to show you guys. That's precious. Okay, time to stop. Time to stop. Okay. It's weird how it interferes with the video signal. Anyway, the next thing I would like to do, and that's going to be maybe for next week, if I choose to do it. Don't know yet if I will. I don't even know where I placed it. But I have an FM modulator for a Sega Genesis to produce, sound from a Sega. I like to do it, but if the Arduino can do it on software, that's probably even better for all of us, because you don't have to worry about it. But, here it is, right here. In this little baggie is the FM modulator for a Sega Genesis. This little thing right here. So we got sound working. It was arduous, but it works. I'm just going to leave this now up to questions. If you guys have any questions at all, let me know. Otherwise, I'm going to end the stream, and I'm going to work on this some more tonight, just by myself, just to figure out why it's flickering the way that it is, and get better sound working. I'd like to at least get nice sound working on it. In fact, I have a testing board with a speaker that I'm going to use right now. This testing board right here is a board my grandfather gave me that I use for testing still to this day. He gave it to me for my 10th Christmas. So, ask questions now. I'm going to be working on this for the next 5 minutes. So, if there are no questions, this concludes the show. And I'll let it run for about 5 minutes and then end the stream. So let me go ahead and just do my work now, and if you guys have any questions, chime in at any time. Any questions, guys? I don't know what you mean by that, Eric. I'm confused. But then again, I confuse easily. So I'm just working on this some more. 42 and 40. Use one of my longer cables here and ground. Any questions, guys? Any at all, just feel free to ask. I figured it out, why it was doing what it's doing. One was using a pulse width modulation while the other one was not. 42 was using pulse width modulation while 40 was not, I believe. Wow, is Frank getting at our monitoring of the show? I don't. Oh, huh? Wow, you guys commented a lot. Holy cow! You guys were on it. Alright, so 42 stays there, and we'll do 3 for the next. What was that? 2. That's 2. Okay, so that being said, okay, 42 stays. The 40 gets changed into something else. 40 goes to 2. Yeah, it's pulse width modulation. Okay. Let's do one more sketch compile. One using pulse width modulation, the other one using an analog signal. So let's see what happens. Or sorry, one using pulse width modulation, the other one using digital, so high or low. And I think it'll change the sound pitch. We'll find out in about 10 seconds. 10, 9, well actually more like 30. It's almost 11 o'clock over here. And are you guys done downloading? Done. Okay. I know there's no music right now, just because it's the end of the show. And I'm just doing a few last tests here to make sure what I'm doing is correct. Because I'm a stickler for trying to get it right. And I am now rewiring it as we speak. To ground. And I hope this works. I'm looking at you guys' conversation right now. already got it to work, basically. That kind of worked. 42? It works. It sounds like it's working pretty well. 42. Yeah. Oh, I got more questions, more comments. So it's doing something, I just don't know what exactly. Which could be a good thing or a bad thing. It's doing something. Something's hitting. I bet you anything I have to use a DAC, like I mentioned earlier. And if that's just the case, I already have one built. My trusty faithful DAC. Right over here. I just gotta remember how the hell I put it together. I barely remember how this is put together. So that concludes our show for tonight. Sorry, there was a bit of a mix-up. Wires are everywhere. So that's it for tonight, guys. Thank you all for joining. This one was a really a lot more complicated episode than the other ones. There's a lot more wiring, a lot more that could go wrong, and that went wrong. And a lot more of me trying to fix and debug things instead of actually proceeding with a test plan or something to do with it. So, now, I know some of you said that you like to watch as I work on this. Now, would you prefer something like this as I tinker around with it, or something more objective with the show? Like come in, show you guys exactly what I did, how I executed it, and then end the episode. It's up to you as to how you guys want to see that. But, yeah, it's the end of this episode. So thank you again for joining, and thank you all for your patronage and joy for what I do. It makes this a lot more fun. But I'm going to end this night off with something real nice. And play some tunes as we carry off this night. So, thank you all again for the 100th time. I will leave that to you.